How is a line plot useful for analyzing and interpreting data? Think about this question during the lesson. How can you use the line plot to describe and analyze the data set? A line plot represents one response with a dot or an X. A line plot with 20 dots or X's shows 20 responses. Part A. A data set is symmetric if it is evenly spread out around the mean of the data set. A data set is skewed if most of the data is to one side or the other of the mean. Is the line plot symmetric or skewed?
Select your answer.
There are more data items left of the mean than right of the mean. The data set is skewed. Part B. A cluster of data is where the data values are grouped together. A gap is a part of a data set with no data values. There is a cluster of data between 0 and 4. Identify the gap in the data set. There are no dots at 7, 8, or 9. There is a gap in the data set from 7 to 9.
Which occurred more often, households with fewer than 2 children or households with more than 2 children? Explain how you know.
The question asks about fewer than 2 children or households with more than 2 children occurring the most. So let's look at 2. Here's 2. So having fewer than 2, we would look to the left. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 dots to the left of 2. So there are 9 households with fewer than 2 children. Then the next is more than 2 children. So we look to the right of 2 children. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there are 10 dots or 10 households with more than 2 children. So which occurred more often? The households with more than 2 children. And that's how we know, because we counted the number of households that had less, the number of households that had more, and the ones that had more were more than the ones that had less.
The line plot shows the heights of basketball players at one high school. Part A. What information does the range tell you about the heights of players on the team?
The range of the players, you take the greatest, which is 80 and 5/10, and then 70 and subtract. And you get 10 and 5/10. So the tallest player on the team is 10 and 5/10 inches taller than the shortest player on the team.
The line plot shows the heights of basketball players at one high school. Part B. The tallest player on the team moves away. His spot on the team is taken by a player who is 72 inches tall. How does this affect the range of heights?
With the tallest player leaving, the range is taking the greatest and subtracting it by the least. So now the greatest is 77 and 5/10 inches tall. So now you subtract that from 70, and that equals 7 and 5/10 inches. So now the tallest player on the team is 7 and 5/10 inches taller than the shortest player.
What was the mean of the original basketball team heights? How does it affect the mean when the tallest player on the team is replaced by a player who is 72 inches tall?
So now we would have to find the mean of the original basketball team heights that included that player that moved away, and we'll be able to better answer the question. So let's do that. So you're going to take the original heights, and that's all of the dots, and each one of them is a number. So this is 70, 71, 72, or 71 and 5/10, 73. These are all 73. Then that's 73 and 5/10 because it's halfway. So whenever you see that dot halfway between, that's where you get that 0.5, and so forth. So again, for sake of time, I'm not going to list them all, but you're going to add them all up and then divide by the number of players. And so the number of players is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So these are the original heights. And so there's that many. So you're going to divide by that number, and then you're going to get 73 and 8/10. So 73 and 8/10 is going to be the original mean of the heights of the players. And then now that this player moves away and is replaced by that other player that's 72 inches tall, you still add the numbers up, but now you're including that 72 instead of that 80 and 5/10 player. Add them all up, divide by the 15, and you get 73 and 2/10. So 73 and 2/10 when the team is replaced by a player who is 72 inches tall. So now the mean changes, slightly, because now the tallest person on the team is not as tall as the player that moved away. So the difference in the two means is about 6/10. If you subtract the two, it'll be 0.6/10, 0 and 6/10. So that's how much the team has lowered its range of height, is by that 6/10. And so that's how it would affect the mean.
Jaime and Liza counted geckos every day after school. After 2 weeks, they made line plots of their data. An outlier is a data value that differs from most of the other data values in a set. Whose data about gecko sightings includes an outlier? How does the outlier affect the data set? Explain.
Liza's data set includes a day during which she saw 2 geckos because, and that's right here, because that data value is less than the others, it lowers the mean of her data. And so this is the outlier because, as you can see, most of her data is either 5 or more, right? Most of Jaime's or Jamie's data is 5 or more. But this one day, she saw only 2, which changed her mean of her data. It's going to lower it because that outlier is to the left, so it's smaller. So it's going to lower her mean of her data. Now, let's look at the chart.
Jaime says his data set is a better indication of the gecko population in their neighborhood because he saw about the same number of geckos every day. Do you agree? Why or why not?
I would say yes, I agree, because outliers are like that one time something different than the usual happens, right? So something that is consistent, like Jamie's data, where he's seeing about the same number of geckos each day over that time period, would be a better indication of that population. on that one day that Liza saw the 2, that's not usual for her, for the neighborhood. So that would be just kind of like a one-off or an anomaly, which they call an outlier in math. So I do agree that Jamie's data would be a better representation of that Geico population in his neighborhood.